Good evening, everyone, and welcome to today's Climate Business Plan Community Meeting webinar. I'm Melissa Adams, Chief Corporate Social Responsibility Officer for Washington Gas, and I will be serving as your moderator this evening. I'd like to thank everybody who has joined us this evening. And before we get started, it's our common practice at Washington Gas to begin all our meetings with a safety minute. During which we share key tips and guidelines about safety. And this is a long-standing part of our culture and a core value, as safety is a top priority for the company. And so with that, it's my pleasure to introduce my colleague, Martel Price, Digital Communications Analyst, who will share a few tips on rushing and mindful activity during what is often a very busy holiday end-of-year season. So take it away, Martel.
Right. Thank you so much, Melissa, and good evening and welcome, everyone. I'm Martel Price with the Corporate Communications Department at Washington Gas. And as Melissa stated, our safety topic today is about slowing things down during the holiday season. Leading up to the holidays, we can feel pressure to meet increased production demands and compressed timelines. These factors can create a sense of urgency that leads to rushing, which can dramatically increase the risk of injury. And then when you pile on things like outside of work, like family tasks, shopping, cooking, and cleaning, these things can also increase the sense of urgency and risk factors. So what are some things that we can do to avoid rushing? Well, the first tip is to try to do a little less, focus on quality over quantity, and remember to handle your most important tasks first. Have fewer meetings whenever possible. And also practice disconnecting. There should be times where we are able to turn off our device and email notifications. Spending time on self-care and not taking any phone calls is also a great tip for slowing things down. You can do things like creating, reading, or just remembering to take a walk is helpful to disconnect. Lastly, build logistics such as travel time to and from your destinations into the plan. Be aware of any potential delays due to traffic or weather conditions. This one is especially true for me. I find that I'm so much less anxious driving and parking in the district when I build some travel time into the plan. That concludes the safety minute. Melissa, back over to you.
Okay, thanks, Martel. And those are great tips. And no matter how busy we are, safety has to be our first priority. So back to the meeting. Allow me to take a moment and set the stage for what to expect this evening. So our lineup this evening includes a brief, approximately 10-minute video update on our progress since we last met in February. And then following that, we're hosting a live discussion with a panel of experts who will share background on advanced leak detection and its application to the Washington Gas system. We will be joined, and I'll share introductions following, but we are very fortunate to have key leaders from Satelytics joining us this evening, as well as MiQ, which is the Rocky Mountain Institute Methane Certification Program, as well as our very own Paul Zohorsky, who's our own vice president. So again, after we do the video, we are going to move into our panel discussion, and then we'll follow that with a live Q&A. So using the Zoom message chat function that you'll see on your screen, please start submitting your questions, and our panel will be standing by live to answer them. Essentially, our format has been developed in response to feedback we've received from some of our previous meetings. It ensures that we keep to our agenda and allows ample time for a more interactive portion of the meeting, including answering your questions about leak detection and its use on the Washington Gas system. So before we begin, a few quick housekeeping items. Again, should you have questions during the presentations, please submit them in the dialog box, and we will open the floor for Q&A after the videos and the panel. All microphones are automatically on mute and cameras are disabled. And if our audio or video are not coming through clearly, please message us. And with that, let's begin a review of some of our recent actions and progress. In March of 2020, Washington Gas filed its climate business plan with the District of Columbia Public Service Commission. In it, we provide a framework that demonstrates our commitment to creating a low-carbon energy future and supporting the achievement of the district's climate goals. Just about a year ago, we supplemented the plan with filings on near and longer-term proposed climate actions, including initiatives to reduce transportation emissions. Through public meetings like this, we will continue to provide updates on our actions and plans to help the district meet its climate targets. Today, we will share the progress we have made since our meeting in February. We will provide updates on initiatives in the 3 core areas on which our climate business plan is centered: maximizing energy efficiency, enhancing infrastructure and operations, and harnessing new and emerging fuel sources.
Washington Gas is currently working to expand energy efficiency offerings for our DC customers to help them use less energy, reduce their energy bills, and their GHG emissions. On October 31st, Washington Gas filed its DC Energy Efficiency and Demand Response Potential Study. The EEDR study, for short, identifies the potential to reduce natural gas consumption and GHG emissions. It also identifies energy-saving strategies that can be implemented in the district. These strategies are based on a combination of proven accomplishments in our Maryland and Virginia territories and new and innovative concepts now being piloted. A few examples of these innovative tactics include the Residential Demand Response Pilot Program, Commercial Online Business Energy Advisor, and the Gas Heat Pump Pilot. The Residential Demand Response Pilot Program automatically lowers smart thermostat settings during peak events. With 5,000 customers already enrolled, we have already seen energy savings during the coldest days of the year. The Commercial Online Business Energy Advisor pilot deploys user-friendly, data-driven resources that provide commercial customers with insights on consumption patterns and strategies to reduce energy and operating costs. The Gas Heat Pump pilot, also underway in Maryland, assesses the market potential of deploying highly efficient gas heat pump technology in the Mid-Atlantic region. Through this pilot, Washington Gas will install and monitor units through the end of 2023 to capture real-time energy saving and performance data to determine market feasibility. Washington Gas will review, analyze, and use all the findings from these pilots to design a comprehensive suite of DC programs that we expect to file next month.
Washington Gas is committed to investing in more efficient infrastructure that prioritizes safety and reliability. As we continue to modernize our infrastructure, our investments will help us maintain a modern, safe, and reliable energy delivery system that will enhance our ability to introduce lower carbon fuels as we meet the district's energy needs.
Washington Gas's Project Pipes program is the centerpiece of our infrastructure modernization effort in the District of Columbia. It focuses on enhancing safety while also reducing greenhouse gas emissions and enhancing the reliability and resiliency of the district's energy infrastructure by replacing targeted older pipe in the distribution system. Doing so will result in less pipe failure and leaks, which also have the added benefit of reducing fugitive emissions that are attributable to vintage pipe materials. In short, the continuation of Project Pipes will enable greater reductions than the company's cumulative reduction of approximately 15,850 metric tons of carbon dioxide between 2014 and 2021.
Washington Gas is conducting a pilot program using advanced leak detection technology that has the potential to identify large emission points quickly and efficiently and prioritize the repair of confirmed leaks. It is a multi-layered approach that includes the use of satellite technology to quickly assess the entirety of our district-based infrastructure for high emission detections. These findings will then be refined with the use of mobile-mounted leak detection equipment that will survey the area that was detected. Those findings will be further refined by technicians in the field that will pinpoint the location of the source of the emission so that it can be repaired or replaced. Rapidly assessing the entire system at frequent, regular intervals and mitigating any high emission leaks will reduce greenhouse gas emissions that might otherwise continue to emit for several years. We will hear more about the potential of these new technologies from our panel in a few minutes.
Washington Gas is also committed to leveraging its extensive energy delivery infrastructure to deliver gaseous fuels that help reduce greenhouse gas emissions when compared to the emissions associated with the production and use of traditional fossil gas. Washington Gas's recent procurement of lower emission intensity certified natural gas and involvement in the Mid-Atlantic Hydrogen Hub and the WSSC Renewable Natural Gas Interconnection reflect our progress in that area.
On May 19, 2021, WSSC Water Commissioners approved an 18-year contract with Washington Gas for the construction and installation of natural gas pipeline and related infrastructure to supply natural gas to and convey renewable natural gas from WSSC Water's Piscataway Bioenergy Facility. The construction of the interconnection site was completed in October. Other supporting infrastructure is in development, with RNG production and project activation expected by the fourth quarter of 2023.
And the WSSC partnership is just the beginning. We are exploring multiple supply interconnections that could enable the delivery of regionally produced RNG to our customers.
Earlier this year, Washington Gas signed contracts with Chesapeake Energy Corporation and Ascent Resources for lower emission intensity certified natural gas. The gas has been certified according to Rocky Mountain Institute's MiQ standard. These transactions demonstrate Washington Gas's ability to leverage our buying power and also underscores our commitment to purchase supply from lower emissions producers. These transactions are estimated to reduce approximately 28,000 metric tons of CO2 equivalent emissions when compared to the industry average. This equates to taking roughly 6,000 passenger vehicles off the road.
We're also working to deliver alternative, lower carbon gaseous fuel sources to our customers. On November 14th, Connected DMV and a cross-sector coalition of more than 40 partners representing Washington, D.C., Maryland, and Virginia announced that the Mid-Atlantic Hydrogen Hub is pursuing one of U.S. Department of Energy's regional hydrogen hubs. Washington Gas is proud to be one of the region's participating utilities. This hydrogen hub integrates a $2 billion portfolio of high-impact hydrogen demand and clean hydrogen production into a regional network of diverse use cases to accelerate scale, drive down costs, and spur innovation. Washington Gas would be participating in a variety of transportation, power generation, and residential commercial heating projects.
We are excited to share the progress we've made in maximizing energy efficiency, enhancing infrastructure and operations, and harnessing new and emerging fuel sources. From our energy efficiency and demand response potential study to our WSSC RNG interconnection, Rocky Mountain Institute MiQ low emission intensity certification, and Connected DMV hydrogen partnerships, Washington Gas is moving forward with actions that support the district's goal of reducing greenhouse gas emissions. So as just discussed, we've been moving forward on multiple fronts to take action on reducing greenhouse gas emissions. And now it's my pleasure to introduce our panel of experts who are focused on one of those key areas, which is advanced leak detection, an initiative that offers great potential as a GHG reduction strategy while offering important related safety and efficiency opportunities. So with us this evening are Lara Owens, who is Director, Science and Technology at MiQ, which is Methane Intelligence, It is a not-for-profit climate tech foundation undertaking cutting-edge work to reduce methane emissions in the oil and gas sector. Lara was previously a manager in Rocky Mountain Institute's Climate Intelligence Program, focusing on accelerating efforts to reduce greenhouse gas emissions from global oil and gas supply chains. And prior to joining RMI, she worked at Mercury NZ and Ormat Technologies as a technical expert, managing exploration and development, process chemistry, operational efficiency, and environmental compliance. And Lara got caught up in the Midwest snowstorm, and we're delighted she's joining us live from actually beautiful South Dakota this evening. So we thank her very much for her efforts. Lara holds a PhD in geochemistry and a BS in geosciences. Also joining us in the panel this evening is Sean Donegan. He is the president and CEO of Satelytics. He has over 30 years of technology and software development experience, and his career has focused on building companies that solve customers' toughest challenges. Through his latest venture, Sean is applying data analytics and artificial intelligence capabilities to better identify and assess GHG emissions, a critical component of effective reduction strategies. Sean is a graduate of the University of London and has postgraduate professional qualifications from the Chartered Institute of Management. And Sean is joining us live tonight from Satelytics headquarters in Ohio. And finally, I am delighted to introduce my colleague, Paul Zohorsky, Vice President of Operations, Engineering, Construction, and Safety. Paul is responsible for field operations at Washington Gas. And in that role, he leads a team of approximately 650 professionals that has responsibility for below ground operations and maintenance, above ground service operations, and maintenance and utility operations, which includes leak survey, damage prevention, corrosion management, and metering. Prior to joining us about a year ago, Paul held several leadership roles at Eversource Energy and its predecessor companies. Paul is a graduate of the U.S. Naval Academy and has an advanced degree from Johns Hopkins. And now, with that, let me turn to our panel. So I think we'll start off first with Lara and ask if Lara could just provide us some explanation and description. What is advanced leak detection?
Thank you, Melissa. I'm really proud to be here with this panel. I'm excited to talk about advanced leak detection because it's something that we're getting to put into place. Right now a lot faster than regulation alone can effectively use for mitigation of emissions. So advanced leak detection, in my mind, really covers a gamut of different deployment strategies. This could include drones or satellites or advanced analytics that are using artificial intelligence in order to be able to understand where the leaks are coming from using a combination of different data inputs. But really the benefit of advanced leak detection technologies is that they have much better spatial and temporal coverage, because we know that the emissions from different parts of the supply chain, moving from the upstream to the midstream to local distribution, cover a wide gamut of different sources of emissions. They have different concentrations, they have different flow rates, and they have different intermittencies. So we really need an ecosystem or a combination of different solutions that can look from the top down much more effectively, rather than necessarily focusing just on a very slow method of covering everything inch by inch. We need to be able to triage and ultimately use the tools that are available to understand this wide distribution of emissions. So, I mean, because there's no silver bullet, because we understand right now there's no one solution that can do this the best everywhere, we have to be able to embrace all these different types of solutions that can look at the different emissions, and that can do it in a way that gets to the biggest sources the fastest. And we know from a safety perspective, this is really key. We need to understand that there's some lower cost, smarter, more analytically driven solutions that can get to the really risky sources. And then we can spend other time using maybe traditional regulatory based approaches in order to do the hygiene, to do the maintenance that is necessary to keep systems up and running.
Well, thanks, Laura. That was a really great overview. And I'm reminded that I just want to clarify instructions for those of you that have questions to please put them in our Q&A box. And that's where we'll be gathering our questions tonight. So great overview, Lara. And is there anything in particular with respect to distribution companies like ours, Washington Gas, where you think advanced leak detection may offer a special advantage?
Well, that's a really good question, and I'm glad that you used some examples from Satelytics that showed some well pads with some of those emissions. What we're doing is trying to give distribution companies access to certified upstream gas. So that gas is known to have a certain quantity or a certain grade of quote unquote leak removal or leak prevention, so that can be assured to your customers that the upstream source of emissions are ultimately reduced. So very near and dear to my heart is understanding how these advanced detection technologies are applied not just to production, but to gathering and boosting, to processing, and into midstream. And we recognize that because there's such a large percentage of your full scope 1, 2, and 3 emissions for the molecule of gas that you deliver to your customers come from the upstream, it's so important to be able to address that. And with your buying power and with your ability to deliver that, you are effectively putting advanced leak detection in place where, previously there might not have been that same incentive for those producers. So your procurement and your ability to be able to address that, is really, really impactful for the upstream emissions. Something I'd also like to point out is that, advanced leak detection has the potential to enhance systems really everywhere. So you guys are dealing with, on your local distribution systems, areas that might need really, really quick addressing of a specific need for repair or need for replacement. And this is something that you might not be able to do with the current regulatory approaches that are put into place. So your election to take on, top-down solutions or more advanced analytical solutions in order to be able to screen for this is really, really going to not just prevent the emissions from going into the atmosphere, but they're going to create a safer environment for your customers. And I think lastly, we're moving into an area where we need to understand quantitatively, or really trying to drive more measurement to our emissions. So this is so that we can be able to compare apples to apples. Is my gas effectively a quantitatively and robustly determined lower emitting product than other solutions that are out there, either for electricity or for heating? So we need to actually know what our numbers are. And the good news is that a lot of advanced technology solutions focus on quantitative solutions, or they focus on being able to compare their numbers apples to apples with other measurement technologies. So what we're understanding now is our numbers are getting better, our inventories are getting better, our ability to know exactly what our risk profiles are getting a lot better, because these solutions focus on measurement rather than just simply, the detection of where they're coming from.
That's great, Lara. Thank you. And actually, I think my next question, I will turn to Paul to just ask him, how does advanced leak detection differ from the technologies and practices that are in place at Washington Gas? Well, I won't say today because we're using piloting some of this technology, but from our traditional practices, what's different? Oh, you're on mute, Paul. Oh, somebody, Paul, you're
hear me.
Thank you.
No, you told me about this, but our conventional practice has been to do walking surveys. We walk all of our infrastructure over the course of 3 years, which is more stringent than the PHMSA requirement of every 5 years. But we basically do a walking survey with instrumentation to look for leaks. And that means we get a third of our system every year, which is good. We also have customers who call in to notice, if they notice a smell, they will call us. But, again, that means there could be a gap in some locations between 3 years if you have an issue, right? And so one of the nicest things, like Lara said, was that hey, you get the biggest sources fastest, right? And some of this advanced leak detection allows us, at least what we're piloting, to identify those locations who could be emission points, and we get out there early when we may not have been out there for another 2 years or so and fix them. And that's really exciting for not only a public safety perspective, but also from the perspective of environmental protection.
Thanks, Paul. Actually, now turning to Sean, can you tell us a little bit more about this satellite technology, about Satelytics? How does it work and detect methane? How can a lens or a satellite thousands of miles above the Earth actually detect a methane plume on city streets? What is it that you guys do exactly?
Well, thanks, Melissa. Great to be here with everybody. Laura, Paul, super to join such tip-top professionals. So Satelytics, with an idea some 10 years ago that we needed to get early adopters, we're using the infrared spectra, and the fastest moving medium that we all know is light. We talk about the distance between Mars and Earth in light years. Light is the fastest moving medium. So light shining on the Earth's surface or even water, and the speciality looks at the reflectance signature that can be seen only in the infrared spectra. Now, specifically to methane, it shows up in what's called the shortwave infrared. The naked eye sees red, green, blue. The shortwave infrared provides the reflectance pattern. So methane has a different pattern to propane as opposed to butane. A healthy oak tree has a different light pattern to an unhealthy oak tree. And it's our ability to quickly turn that data into telling you what it is, where it is, and how much, or what's the severity of the emission. So the key here for us as a company was within literally hours of receiving the data, how quickly can we crunch that and get it to actionable data to the field service crew that Paul talks dearly about that are walking the line. What are the benefits to this? So it's really pretty straightforward. Early detection means less emissions and prevents disasters. I mean, let's just call it what it is. We started with the upstream. Our biggest customer in that field is BP around the world, tests us in 65 countries, ground truth, so we know how accurate our algorithms are, and we constantly ground truth. We use at the heart of our software something called artificial intelligence. For those of you fellow propeller heads, it's called a convolutional neural network that constantly improves with more data and feedback. And of course, even some of the clients and partners that came up on your video, Baltimore Gas and Electric is coming online. National Grid this morning came online to start its pilot program. So it's something that's being adopted by your peers. And as a thought leader, Washington Gas has really pushed the envelope. The interesting thing about this is today you can look 3 or 4 times a week anywhere in the world with a satellite. And within 3 to 4 hours, you're actioning on the data that we provide. By the turn of this century, that will be every few minutes. The amount of money that's being spent above the Earth's surface, which are effectively the eggs in the mixing bowl, if you think you still need the flour, the milk, the baking, and the mixing before you can get to the results. That's where we come in. But the amount of money that's being spent above the Earth's surface is staggering. And you'll be able to look multiple times an hour as we go into the next century. What's good about that? The bottom line is safety for the environment, for people, your customers, residential and businesses, but also one very key ingredient. That's the team at Washington Gas, their safety too. You're now sending expert resources only to areas where you have a very high degree of confidence in the emissions that are coming out, with a precise location and some idea of that emission. And then the experts in the field grade it, and you go through what's required by, legislation to follow the remediation of those sort of efforts. So that's a snapshot of what the technology offers.
So Paul, with that in mind, with that in mind, and the fact that we've done several flyovers now, we've gotten the data back from Sean. What is it that we've learned? What were the sort of main takeaways that we got out of our several flyovers? And how did it go for us?
Well, I think it was a great pilot, and we're going to be continuing this as we move into 23, where we're going to do more of this. However, as Lara said, I mean, there's a lot of different technologies that can feed into this AI. So we want to continue to explore lots of different things. But from a Satelytics perspective, the idea of you get precision. With a mobile survey, you don't get precision. There may be some methane in the air, and it's dependent upon where the wind is blowing it. It's very hard to trace back to its source in some regards. What's great about Satelytics is the precision of its placement. We did some, not only precision of its placement, but also the emission rate. A lot of times we've never been able to quantify the emission rate, which goes back to what Laura's saying. I mean, you want to be able to identify those locations that have the highest emissions and fix those first. So the fact that you can pinpoint and you can get an emission rate allows you to say, hey, this is what I should address first. And that was very exciting. We did a couple of blind tests for Sean and his team where we actually set up an emission point and tested them with a measured flow rate and a location. And they did very, very well in identifying that and getting within, we'd say 10%, if our instrumentation is correct and what the flow rate is coming out of that pipe. So that's very exciting. We have some false positives. So we actually get more positives than we like. And you get some of that because of, we're finding you get reflections off swimming pools, you get reflections off of the solar panels, you get other things that cause impacts. And then a final thing, which is kind of interesting, is we also can detect emissions behind the meter. This is customer side emissions. Let's just say on the roof of buildings where there's gas equipment, or you can go to, we all know we've had COVID around for a while. A lot of people have put up their restaurant eating areas out on the sidewalk. You can detect propane and other leakage or methane leakage from the heaters on those that are out there. So you get behind the meter information too, which is, I think, positive because, you can help address that too, which is a leak or emission that you would never, ever see by just doing a walking survey. And I guess those are a lot of the good wins from this perspective.
So that's great. It sounds like maybe a potential assist to customers in the future, as well as running efficient, safe operations, ourselves. And then as we went through, I know we're still a little bit in early days because that was sort of initial pilot, but did we see changes in the data coming through, with respect to each flyover? How did the artificial intelligence piece of it work?
Well, that's a good question. Yes, we did see, we were feeding back. I mean, Satelytics would give us the data. We would go out and do walking surveys to grade these emission points, and some did not come up. And so we could feed this information back. We worked very closely with the Satelytics team, and we determined we could come up with reasons why this may not work, which allowed them to continue to tune their artificial intelligence. I'll call it an engine, Sean. You used a very big word. I use a smaller word. But we continue to tune that so that as we progressed through these surveys, we had fewer and fewer false positives and more accuracy and what was determined to be a real emission.
Okay, great. And so going forward, there's, Lara mentioned a lot of technology out there. Do you see us engaging and working with other technologies as well, Paul? You mentioned a lot of the benefits we see with satellites and AI that's, running behind that. What else do you see for us? I know it's a little bit, looking out to the future, but.
Well, what we're looking at doing in 2023, a sort of, we call it a hybrid, model, where we're going to use satellite initially to detect these emission locations, and then we're going to send a mobile survey vehicle out to that location to see what kind of confirmation we can get using mobile surveying. And then we're going to send the ground truthing team out, the folks who are on the ground, who are going to pinpoint and grade the emission if it's a leak. We think at this point, using all of those technologies will give us a better feel for the effectiveness of all of them working together. And I'm just, I think the long-term opportunity is where we're going to go with Satelytics is the almost near constant coverage of your distribution area using satellite technology that allow you to, again, get to the biggest locations with the biggest leaks fastest and repair them quickly, again, to drop overall emissions down. But at this point, we still want to pilot. We want to use these technologies together to help us, again, learn. But I'm very excited about what we can do to really repair leaks very, very quickly.
Great. That sounds wonderful. I know I personally am excited about this technology and what it holds for the future. And maybe just a round robin as we go across the panel, maybe starting with Lara, because we want to get some time to answer our questions that are coming in. But is there anything more that you guys, each of you would like to share about how this ALD technology can help reduce greenhouse gas emissions? Something we may have left out or overlooked this evening. So I guess I'll start with Lara.
Thanks. I mean, one of the things I'm really encouraged by is how, we're talking about satellites being able to work and effectively, pinpoint emissions at a very, very small spatial scale. And that's really incredible. We need to be pushing the envelope and continuing to push the envelope. But I think one of the great things about these solutions and these solution providers that we're talking about today, and we call them that because, it's not just a sensor in your hand, it's the sensor plus the analytics, plus the algorithms, and it's all combined to create sort of a solution. And part of that solution is the data collection, the data aggregation that comes from these surveys. So we're in this world right now, we're really understanding where our warts and boils and bubbles and biggest risk areas are as an industry. And so as we collect and understand this data, we're going to have better information a year from now, 5 years from now, about what our biggest risk areas are, so we can move to engineer out those risk areas. So really, at the end of the day, we want to be able to create the most leak-free system, in the world, and really be able to use these technologies to get there, to make themselves, irrelevant.
I guess I'll turn to Sean and see, is there, anything else you'd like to leave with people?
Well, I think Laura's right. You look at the end-to-end solution as a real key. One of the early adopters in the local distribution network for us was Duke Energy. And they have, Paul and team have learned from their experiences and best practices. In fact, what's interesting is it doesn't just become about emissions and early detection and repair, but it also gives Washington Gas an aggregation of what is their carbon footprint per quarter, per month, whatever the frequency is that you capture. So you can literally show your stakeholders that as you replace pipe, as you put in new methods and technologies, you're lowering your carbon footprint, reducing your emissions, not just from an emission perspective, but from an overall corporate standpoint. I think that's incredibly critical. Number two that I would suggest coming this year are other entrants into this market as other satellite companies, which will reduce the cost of the data, making this data more ubiquitous and consumable. And then number three, people like Duke, just a simple aside, same data, same analytics, they now saving millions of dollars by knowing the optimal time to run in their gas services to any new construction. And in their catchmark area, previously it was people driving by with trucks almost daily. In their catchment area, they have very fast growing cities like Charlotte and Nashville. And so it's important that they use resources widely and run those new services, and they call that housing starts. But it's also using the same data set, just in a slightly different fashion.
Okay. Well, thank you, Sean. And Paul, is there anything else you'd like to add before we?
Well, I'm going to jump on a little bit what Sean was saying. I'm looking forward to the ability to capture, again, with frequent flyovers, looking at all the emissions, capturing our real and quantifying our real emissions rate at Washington Gas in an empirical way. And right now we use models that are old, and I don't have a lot of confidence in them, but real data, and then we can show by what we do, the improvement we've made, and in our system. And I think not only would the public would like to see that, and our customers would like to see that, but my folks who work at this will take a lot of pleasure in saying, "Hey, I do this, and look what happened." And so I'm very excited about being able to measure this empirically and reduce it in a measurable way. It's a win-win for so many people, customers, the public, and my folks.
Yeah, and if I just comment on that, it's so important having this technology. It's at the sort of forefront of the new sort of direct measurement, if you will, initiatives that both our NGOs are focused on, universities in partnership with utilities, upstreams all around. There's an initiative by GTI, Gas Technology Institute, called Project Veritas, which is trying to establish protocols across the whole value chain so we can get beyond sort of what I'll call desktop measurements that use, sort of average factors to start to move to see where we really are. So as Paul said, we can see the benefits of what we're doing. So having this technology available starts to make that type of activity a possibility rather than just a guess, which is what pretty much what we do right now. I mean, not we, but that's how emissions are calculated at the moment. So getting more and better data that continues to improve is so important to validate what we're doing and move forward. We are getting some questions, so I'm going to share some of them. Somebody asked Sean about, did I hear that right? BGE and National Grid are using Satelytics too. You mentioned Duke, and I was just wondering what other LDCs, if it's fair to share, I don't know, are also investigating.
Yeah, literally this morning I had a kickoff meeting with the National Grid. Baltimore Gas and Electric, an AOI has been selected. They start in January, but we have other clients like NiSource and other Fortis, Central Hudson Gas Electric, and many others using Satelytics and sort of a couple of steps advanced. Southern California Gas is starting in January too. So you're seeing a large number of your peers and colleagues who, for all the same reasons that Paul's very expertly outlined, I mean, Duke and Washington Gas are sort of visionaries in their field, and they've sort of blazed this trail. But of course, in the upstream and midstream, we've had clients using this for methane across the world for many years.
Okay, thanks very much. And I will also then ask, I think as you look out at the horizon, we had another question coming in. What do you see in terms of future developments? What's next in this space?
Well, for us, selfishly, if you look up the value chain, so midstream, upstream, we're looking at things like H2S, which is a very deadly gas. We're looking at gas speciation. NOx and SOx is the term that's used in the language in that area. But I think in the local distribution market, with our partner Duke, we are getting down to very, very low levels of detection. In fact, I'm on my way there tomorrow. We're conducting an experiment with a great academic body in the United States to give a lot of results and blind tests and studies. Today, we see less than 1 kilogram an hour, or I think that roughly is 8 skiff to a flow rate. We're experimenting and detecting to much lower levels. And that's one area where we're improving and in what we can detect and quantify. That's obviously very key to the result. The other area, of course, is in the actual data source. There'll be 2 new entrants to this market within the next year to 18 months, Wyvern and Pixel. That will drive down the cost of the data. It will also increase the frequency of capture. That's going to be quickly followed by Planet Labs with a series of hyperspectral satellites. Again, all of this adds to ubiquity of data, frequency of data, which ultimately gives a much better blanket for your customers and your employees alike, that you can detect early with a great deal of accuracy and quantification, which results in action quicker. All good, all positive. Planet, people, and the outcome for the company's goals.
Okay, that's great. I'm just going to go and we've gotten some other questions now, not directly on advanced leak detection, but one of our listeners asked about the net zero carbon targets of the District of Columbia. And even assuming new energy sources are lower emission, they're far from zero. How is WGL getting to zero emissions in 12 years? So I would say, fortunately, it's not 12 years. Our plan that we developed was based on the original targets in the district, which were 2050, but the new legislation has accelerated that to 2045. So there is definite more urgency with respect to the things that we must do to get there. But luckily, we do have more than 12 years, so, because it is a big ask. But our plan does outline the initiatives we intend to take to half our emissions by 2032. And those, the framework, as well as climate action plans and the roadmap we have are on our microsite. So, and some of those areas we go into greater detail in the preceding webinars we had. So I would encourage those listening tonight to also check out some of our earlier webinars where we discuss some of those areas. But our listener does tee up an important issue. It is a big lift. We have a lot of work to do to make the reductions that we need to make. And they will come in multiple areas. They will come through energy efficiency, helping our customers use less energy, use it more efficiently. They will come through things like, enhanced appliances, as well as hybrid use of gas and electricity, combined heat and power. So we have a number of items in the end use reduction area that we targeted, as well as, running a tight low emission system. And that's what we're addressing in part this evening, as well as sourcing and supply. And so in that plan, we identify our aspiration to use either lower fuel sources, whether it's conventional geologic gas that is, as we discussed tonight, certified to achieve low methane emissions intensity, or introducing things like renewable natural gas, as well as hydrogen that's produced from green energy. So there are probably about 13 major tactics we outline in the climate business plan, and then discuss a little further in our roadmap and climate action plan. And that is really the purpose of holding these meetings, to kind of dig deeper into each of these topics. And again, tonight's focus was to learn a little bit more and speak with experts on advanced leak detection. So I already asked you guys for if there were any closing comments you wanted to make. And I am personally very appreciative of your time and very excited about what we're doing in this space and what we're learning. And I see great opportunities and potential to improve safety, to improve efficiency, and to improve the rapidity with which we find, detect, and ultimately fix emission points. So I want to thank you all for joining us this evening. I want to thank everybody who's taken the time out of their day to join us. And again, encourage you to go to the Climate Business Plan microsite, where we will continue to post. This will be recorded and shared, as well as any other updates and information that we have. So with that, I would like to say good night and thank you very much.